up too much from the remote side. And then Paul is our stand-in, loading everything today and for everything he does all the time for us with lots of support. So thank you to all of you. And then a big thank you to Will for doing a lot of the planning work that I would have normally done because I was working at HRD at the time. So thank you, Will. All right, so this is our last session. I will hand it off to our co-chairs, Will and Gus. Take it away.
All right, thanks, Aaron. And yeah, we got Frank Indiviglio, CTO, on the line. Frank, are you there?
I'm here.
All right, we'll have you kicking off the start of this final session. You know, we like this, as opposed to the last few sessions where we saved all the questions and comments to the end. I think we'd like this to be more of an open discussion. So, you know, we'll have comments throughout, but I'll allow you to give the opening bid over here.
Sure, and yeah, and I encourage the discussion, right? My intention is not to talk for the whole time, is to really kind of have a back and forth. But I'll start off with, you know, just a little introduction to kind of set the stage. I think everybody knows me, just in case you don't. My name is Frank Indiviglio. I'm the Chief Technology Officer here in the CIO's office. I've been the CTO for about 3 years, and before that, I ran the HPC program in the CIO's office for about 5 years, and before that, I worked at GFDL in the HPC team. So I've been here for a little bit, and I've talked about HPC a lot with you. So my first slide, if we go to the next slide, is in the past, right? This is the first slide I think I gave you back when I took over as the deputy director. And there's a lot on the slide, right? There's 16 petaflops total on the slide. There are 3 vendors and 2 architectures, right? We had GPUs and mostly x86. And, you know, it was a sizable program then. It's probably about, you know, 80 to 90 million core hours a month, backed up by all the infrastructure that we had. But really, it's a good starting point for this discussion, right? We're now, you know, 6 years into the future. So let's take a look at what's really changed, right? So if we go to the next slide, this is a somewhat current picture. You had some updates from Leslie this morning, so this will grow pretty soon. But right on that slide right now, there's 67 petaflops, and one site, you know, one partition on one site has more core hours than that whole program did than we showed you before. And that's a good thing, right? Our problems are getting bigger, they're getting more complex, the resolutions are going up, we don't need more compute. So here, and there are changes, right? There's growth, right? We have a cloud component we talked about yesterday. Again, those systems are growing. There are only still two architectures out there, right? There's x86 and some GPUs, and that'll grow, but still, right? We're living in a world where we have 2 architectures, and there's only about 2 vendors still. So we have kind of not cloud in the cloud. The cloud makes it 5, and that's a good thing. But I think, you know, the program has grown substantially over the time that we've been talking, and continue to do that. And I think so. Compute growth is not, you know, the thing I would focus on moving into the future. But I think the things that we've learned and the things that we're going to learn in the next couple of years are really the things that will help us all along, right? So as we've added that cloud component, it's taught us a lot of things about software. I think the lines will blur a little bit more across from, you know, on-site to cloud, back and forth. We have to think, I think, a little bit more data centrically. It is a lot less risky and cheaper to move your job to the data rather than to move the data to the job. Those are hard things. We're not going to get to them in the next couple of years, but things to think about. And I think, you know, we live in kind of an interesting era in computing, right? You know, next week is supercomputing, and you'll see announcements in the press if you watch that stuff. I do, because, you know, that's what I do for a living, but you may too. You'll see things like you can buy a 10 petaflop rack, right? So computing is getting very dense, very power hungry, and very available. And that's a great thing. But how do we bring this stuff all together so that we're moving the science forward, we're moving the computing platforms together so that we're making your life easier rather than, you know, just growing a compute imprint or footprint. So if we go to the next slide. given that, I think, what are our goals? What should the goals of any technology program, not necessarily the HBC program, but what are the goals should be for us working together, right? I think it's reducing time to get productive. So I switched it to maps. There are two different snapshots in time. And what do I mean by reducing time to get productive? Those systems that were there and continue to be there and have changed over time. For you to move from one to the other takes a long time. It takes a lot of work. And I think that's something that we can focus on from a software perspective to make your lives easier, to get people back and forth from systems quicker, to reduce that impact of we may have to change because we don't have enough capacity or whatever it is, right? And that's something that's attainable, right? There are lots of tools out there that can abstract an environment without losing a lot of performance. I mean, there's still give and take, and over time those will get better, and they have gotten better. But in a perfect world, right, you should be able to move from cloud to on-prem, from Hera to Gaia to Orion, whatever, without too much kind of rewriting workflows and redoing things. So I think there's going to be a focus on that software side in the future, and it should be, us all working together to get that kind of focused together across the community. So we're really making the computing environment not just available, but really, give it the capability for it to be usable across the enterprise rather than just, where you call home in your computing parlance. And I think we're on our way there, right? If you go to the cloud providers through the program, you get a very similar environment, if not the same, through a single interface, right? So those tools can be translated back to on-prem and kind of back and forth. So those steps we're in the first couple of steps of that, but I think that's kind of part of the discussion that I think we need to have moving forward. Access to technology faster. We tend to move slow in terms of acquisition cycles and everything else. And I think, how do we find a place where we can get technology faster into people's hands? And I think, we're doing that a little bit in the cloud side, right? You have access to new processors, maybe processors that you're not generally using, and test things out. But really, you have to speed up that cycle. It's not really just buy the next thing and then let's test it out, but it's really find ways for people to find the things that they need faster. And then faster engagement and adoption, right? Now, I'm the CTO, and this is going to be my only CTO joke. They pay me to say AI at least once a presentation. There, I said it. But I think AI is going to drive that, right? As we incorporate more AI into our HPC or generally across NOAA, the pace of change in the AI space is way faster than it is in other computing areas, right? So software, hardware, services will change weekly, if not daily. So we have to start thinking about how we engage with technology and how we adopt it, or can we adopt it faster, or how do we test it further out? Because now our acquisition cycles and things that are deployed don't match, right? So by the time we buy it, we have to be sure, right? So how do we test these things? How do we get engagement models where you get the things that you need, we're testing the things that you want, but we're not, committing to them in a large acquisition, or we're not committing to them in a lot of work that we'll have to undo if it doesn't work out, right? So I think those are the goals across, what I'm looking at, right? With between HPC, AI, and other places, right? How do we speed up the software cycle? How do you make them more productive? And how do you access technology faster? I think, again, we've taken a few steps towards that through, things like cloud, things we've learned there, having that ability to reach out to the cloud and grab the hardware that we need. But I think this has to be, kind of refined as we go forward to make sure that we're providing you guys with a platform that works, and also making sure that we're getting that platform refreshed at a pace that works for everybody. All right, go to the next slide, please. So what if we look at the HPC market, what do we see, in terms of trends, right? So this shouldn't be a surprise. I think, I've said this more than 1 year. There's increasing heterogeneity in hardware and software. An HPC system is not, it still may be, a monolith in terms of there's a predominant architecture and maybe a supporting accelerator. I think that will change over the next 5 years, where, as things like quantum and other parts and pieces come into play. I mean, there are now ARM chips that are available, and do they complement x86? Do they surpass them? We don't know. We'll find out. But I think from a wide view, systems will become more complicated, hardware and especially in software, right? With the mix of HPC and AI software stacks, they do not perform the same way. They don't do the same things. They don't have the same goals. HPC is looking for perfect I/O and best performance, and AI's speed. So how do we get those two things to play together, work together on systems that may or may not share those workloads? But how do we leverage both sides of the fence, so to speak, so that we're incorporating AI where we can, and we're protecting the HPC stuff that we have to. And because we have more choices, right? We have to have flexibility to allow for integration, rapid deployment, development for emerging and growing workloads, right? So looking across NOAA, I mean, we're talking about HFIP, so I am focused on weather and climate here, but fisheries and other parts of NOAA move a lot faster in terms of software. So how do we? Again, it's a usability trade-off, right? So how do we bring all these choices to you in a way that's accessible and that we're not hurting each other's workloads as we get there? It's kind of a hard software problem. It's one that I've talked about, and I'm sure you guys have heard me talk about for years now. But really, it's how to balance that software environment so people get what they need and they're portable. They're not kind of stuck into an architecture or stuck into a system architecture. Cloud continues to grow. I don't think that's a surprise to anybody. It's one of those things where we're going to have to, the lines will blur probably. Will systems become hybrid? Maybe. I think, overall the systems will become hybrid just because we're always looking for new capacity, and that seems to be a way we can get it. Cost effectiveness is another just story, but if we're able to surge into cloud for specific workloads or use cases or things that we need right now, maybe that's a possibility, right? So it's going to continue to grow, if not through a cloud provider directly. Certainly the software and hardware, or the software lines, will blur a lot, and I think that that'll mature over time. And in terms of AI and ML, we talked about it earlier today. We talked about it yesterday. Everybody's talking about AI again. They make you say it once in presentation. I'm kidding, but it really will start to change the way we do business on the HPC side. Not because of how we need to do business, but we're going to have a lot more. We're going to have more AI workloads. Do they run in HPC? Do they not? How do we make these things work together? And because it's a shift, it may be a comfortable shift. I don't know, but because it's a shift, we'll have to kind of work through it together as a community, right? How do we make sure we get it integrated, get you what you need, get your projects forward, and we're not hurting the projects that are already running? All right, next slide. And I'm going to wrap this up pretty quick. So, and I think we have to start looking at the whole value chain rather than just HPC as the central point, right? Which kind of is that box there. Processing is becoming pervasive across all the areas, right? Whether it be, observations to distribution, dissemination, whatever you want to call it. I think those are the things that we're going to have to start thinking about in terms of how do we spread that processing across those areas. You see things at the edge becoming very smart, right? I mean, putting smarts into something in the field is pretty cheap now, relatively speaking, right? So that changes how data gets processed, how data gets pushed back, right? So it may change your workflows across there. And technology improves, we need to kind of step back and take a look at the chain as a whole. How does it work, right? It's not just about the HPC system. It's about the data and the processing that goes on around it. How does that capability flatten or processing across those areas, and how do we deal with it? And then, as things become more remote, more field-based, more smarter in the field, we have to think about infrastructure, right? We're very comfortable with our infrastructure on the HPC side because, it's all well interconnected. We kind of focus on it. But that will change with things in the field, obviously, right? We have to think about things like Starlink and everything else, right? Security. I know, this is not normal. That's not normally my the thing I have to talk about, but security is important. We've got to make sure that things at the edge, as well as things in the middle, are secure. And then how do we balance the software across those things, right? So there's going to be there may be lines that blur between those boxes as well as there are lines that blur between the HPC systems. So how do we kind of manage that and get those software stacks in the right place? And one more, I think. All right. So, and this isn't new to anybody, right? We need to have uniform growth across R&D and operations to make sure that our mission needs are met. We need to effectively invest to innovate with technology, right? Capability through software, capability through hardware, spanning across the cloud and everything else. But I really think that third bullet is becoming more prominent in my mind about how we think about this. Is right. It is how do we build towards that future state of continual computing, right? It's where HPC is the engine, but all the parts of the car now have capability, and how do we stretch across that? And then modernization, right? I think you all, not me, need to be in the driver's seat in terms of modernization. But how do we get there, and how do we modernize so that you have a portable software environment that runs efficiently and gets your job done, and that meets the needs that we have? And I'll stop there and open it up. And I've talked for 15 minutes. I think I actually hit the mark. So I appreciate that. And so I'll open it up for questions, concerns, comments.
Thank you, Frank. Yeah, I think that was a great introduction. Nice set of slides there.
Hey, real quick, Paul, can you bring it up so we can see the chat just in case any come up? Thank you.
Maybe the pictures of that little icons. Let's see. Looks like Fang Lin would like to kick things off. Gus is a little closer than me, so.
This is Daniel from SFEMC. So I've been working on the operational model. So Frank, I have a question for you. As we have this computing power increase more and more, and the data storage is still issue. For official data dissemination, we are still using the FTP nomads that really limit our capability of sending more and more data to the forecasters. And cloud has been demonstrated really useful, quick and fast, like a node. But the forecasters cannot use it as a day-to-day operation. So what's the plan in the future?
So I think, you know, I don't have a direct answer. Like I think we need to improve. We're going to improve data storage, but I think the key point in your question is how do we improve, you know, the dissemination. And I know that is an active discussion, right? We have lots of channels, right? We have the Nod, which is the open version. There's nomads, there's other things, and I think they work in concert. But I think we're gonna have to start thinking about, you know, the other thing that I you know, this is a really good point, right? So the other thing that I didn't put in the slides was the data part of this. So thank you for bringing it up. I think that it's not just how we get it out to people in terms of dissemination. It's going to be how we present it to people. You know, as we want more and more data to be available, you know, people throw around the term AI ready, but it really matters, right? People are going to want to change. Like dissemination has to get smarter to put data in the formats that people want, right? If we're going to use it for AI, it's got to be in a different format, maybe, I don't know. And right now it's on the person who downloads it, right? And that probably won't work in the future. So I think there has to be a better forming of strategy around it, but I think we have to start thinking about how we're going to get data out to people in a very understandable way. Because right now, even if you go to Nod, right, it's hard for me to find data, and I kind of know what I'm looking for. You guys know better than I do. I kind of know what I'm looking for. And it's hard to find data, right? So how do we, yeah, it's more than just the how we do it. It's the or the mechanisms that we disseminate along the data catalogs and the formatting and do we have, right? So I mean, right now we're going to grow the services that we have, but I think we have to think about how we grow the services. And I know that wasn't really a direct answer, but that's the best answer I have.
Yeah, thanks, Frank. I know it's a difficult question to answer.
Hey, Frank, this is Aaron. I have a kind of I guess a question. So I've had multiple conversations with people about the way we run on our code on the HPC, and most of the scientists that do development are developing for specific cores, and then we have problems jumping from system to system. I know you and I have talked about being more scalable and capable of moving everywhere. Is that something that the OCIO or CTO could help with, is getting software engineering expertise that could help it be coded so it's not core specific? Because that's something that these programs don't have the funds, because software engineers for a living are way too expensive for us.
So let me differentiate something in your question before, right? So I think the core specific is something that we'll never get away from, right? People want the performance, right? They're gonna have to recompile if they move to a different architecture or different generations, maybe, right? But what I think is the bigger limiter is the workflow parts, right? Like, people get to a system and they write for that system, and everything kind of that executable, that needs to get tuned to run. Everything around that is tuned for that system, and I think that's where the biggest gain is, right? So you may have to recompile if you go from Hera to Gaia, and I don't know if you have to, don't quote me, right? You guys, again, know better than I do, but the workflow parts and pieces are so different that you'll have to start rewriting things, and I think that's the big limiter. So I think that's where the focus would be, like, how do we containerize these things? How do we provide atomic parts so that when you get there, your workflow has, we were educating each other enough that, like, okay, I know how to transfer data. Here's the thing I have to do, and this is how it fits into the workflow, right?
Right.
Easier said than done, right? It's going to take all of us, not just us, right? It's everybody together. But so I think we have the CENA program. There are things that we can do. Do we have to augment that and add more to it? I think we do, right? Because what I don't want to get into is, where the program becomes the owner of our workflow, right? That is not because, we can support anything. However, you guys own your workflows. You have the best view of the world from your workflows. There's no way an investor going to be able to grab it, right? So how do we work together so that your workflow folks and your software engineers and our software engineers can kind of work together to put those pieces together to make you successful? And for the folks that don't have, that kind of background in their programs, depending on, what the situation is, right? How do we build those structures where we can bring people in from maybe the outside, right? We have contracts, right? Everybody's got contracts. So how do we set up little, I hate using these words, but like little centers of excellence or whatever, where we can bring people together, program staff, HPC program staff, and like maybe industry, to kind of bring together and get some knowledge transfer so that people are getting smarter about this stuff, and we're helping each other get to that end goal of getting our jobs done, right? So there's a couple ways to get there, and I think we've been thinking about ways, but I'm open to suggestions, and that's going to be one of the things that is in my kind of initiative or objectives, right? The things I'm going to focus on for the next couple of years is going to be that development piece, right? We have a very disciplined software development structure in NOAA. It's not shared across NOAA. Every little part's got their own, and there's nothing wrong with that. But then how do we kind of develop the skill across NOAA so that we're helping each other out, right? And that starts with tools, but at the end, it's a people thing, right? So and we have the talent, right? How do we get them connected? That kind of stuff. I don't know if I answered your question, Aaron, but that's
no, that was fine, Frank. I think my non-question and your semi-non-answer actually merge well together, because the whole point is that we're thinking about these things of how we move across our systems and not make it cumbersome or broken. So thank you. I think Hendrik has a question.
Sure.
Hi, Frank. This is Hendrik. I want to add to that. I agree with you that workflow is a big issue, but I think we have a bigger issue in general. Basically, with the transition from CPUs to GPUs and TPUs and things like that. This is the first time in like 25 years that we actually are moving to a really different architecture. And at the same time, we're having issue with scaling our codes properly. We have issue with potentially fault tolerance. And if we really want to do this as a broader community, then we need to make sure that we have codes that are working both on CPUs and GPUs at the same time. And so I'm going to talk to you the next few weeks offline about that. But on the UFS side, we have been talking a little bit about actually coming up with a little bit more high-level strategy of what we want to do, because the bigger question is, are we going to optimize our code again and then need essentially two codes, one for a GPU or a TPU, or are we going to go into this new field where we write our codes on a higher level and then have automatic code generation for the specific hardware you create? I think that is the other part of the discussion we need to have. The fact that that there's only very few of us around that were here when we went from the Cray architecture to the parallel architecture. So I'll be in touch with you about that later. But I do think we need to actually come up with a strategy how to deal with that looks at from a much higher level, because we are quite at a unique situation right now, and with both opportunities and needs at the same time. Thanks.
No, I agree, and I think some of those activities are going on, and you're involved in them, right? So, but I think you're right. We need to kind of look at it from an organizational standpoint. Maybe UFS is the place to do it. Probably is. But I think, again, how do we leverage what we have, and what else do we need? Do we need to bring in, right? GPUs are, do we bring in industry to help us? Do we have creators, we have past, like, what's the kind of superstructure that we need to get you where you want to be, right?
Yes, and yes.
Mm-hmm.
And yeah, I'm glad you pointed that out, because this is really one of those places that if you're starting to write, to think about different ways of writing our code in general, this is consistent with the fact that we are trying to separate out the science work from the software work. The fact that we've realized that we cannot really pay a contractor enough to be a good software engineer, but we can buy software engineering as a service. And so we need to think about all these things. But I think that the biggest problem we have right now is that we have a lot of smart people doing things, but we are looking at little stovepipes of things are being done differently in different places of the big community, which is a good thing, because diversity helps you figure out what to do. But at some point, if you really want to have a complex, unified system that works everywhere all the time, then you really need to start thinking about a high-end strategy and start following that.
I agree. I mean, it's good to have that diversity, but there's got to be communication too. And I think, going back to the people thing you mentioned, right? Like it's hard to find folks. It's really hard to pay them. But we have to think about how we're going to develop that talent, right? Because, at a base level, right? You and I speak a little different language, right? We kind of meet in the middle, right? But they're in the Venn diagram of science and technology. There's that really nice slice in the middle where people speak, they can speak across both languages. We have to start developing that across all of our organizations, so that when we start pulling the software engineering, the science together, they're not at odds, right? There are people that kind of span that.
This is Fang Ling Yang again from EMC, and to follow up to this discussion on. So for the physics example, I've been trying to push to convert the code to GPU, but there's always lack of support. I think hopefully in the future, when we procure a GPU, if the transition more and more to GPU chips, consider how to put aside some funding to support the science work to transition into the code. This really has been like, and we also have new computers, and then we don't have models to run.
Okay. Yeah. Well, so you mean support? You mean people support, right? You're not talking about technical support. Yeah. Okay.
Human resources.
Yeah. So I think you're right. We have to really think about that, how we do that, and I think that's going to be like, we don't have enough capacity. We'll never have enough people, right? So how do we build that up? But there are ways, right? So short-term kind of stuff, right? We have creatives with people and they're willing to help. So if you want, you send me an email. I can follow up with you. We can put you in touch with folks. I mean, it's not going to fix all your problems, right? I can't promise that, but if we can push in the right direction, then I'm happy to do that, and we can start working towards how to fix these problems. But let's work with what we have and then start building for what we need. But I think you're right. We have to think about SINA and software engineering and all of these things across the board, and really kind of, like Hendrik said, think strategically how we're going to get there, kind of thing. And I think that's part of what we're going to try to get through the next couple of years.
All right, I think with that, in an effort to stay on track, we'll close out that part of the session. Let's all do a round of applause for Frank and Divizio.
Thanks for having me. Sorry I couldn't be there in person or turn my camera on, but I appreciate being part of this every year. And I promise next year I'll be there in person.
Sounds good, Frank.
Thank you so much. I always enjoy our conversations that you and I have, either with small groups or just the two of us.
Mhm.
And it wasn't any different today. They're always great about the types of ideas you come up with. So thank you.
Thank you.
All right, so with that, we'll turn it over to Wallace Hogsett of the National Hurricane Center, who will be facilitating a discussion about forecasting, which is a very generic topic. So hopefully we can nail that down to a few more specific ideas to discuss.
All right, we'll see where this goes. So I'm just going to throw out some ideas, some topics that have come up throughout the week. I've done a little brainstorming with our team on the side over beers at happy hour, and I think there are at least 8 or 10 Hurricane Center folks still on the call here. So for all of you, my Hurricane Center colleagues, raise your hand as I'm talking, and I'll hand it over to you guys if you want to add anything at the end. But I've got 3 things I want to mention. These are kind of themes that I heard that are very relevant to what we do kind of at the end of the value chain at the Hurricane Center. So number 1, HWRF and HMON. We are going to, you've heard it, we're going to lose HWRF and HMON soon. If we lose, or when we lose HWRF and HMON, assuming no other changes, no, Lou, no slides. I made an executive decision that we've seen enough slides and we need a break. All right, so HWRF and HMON, when we lose HWRF and HMON, if nothing else changes, our forecast skill for intensity will go down. So as a community, I think we really need to think, like, how can we maintain some of the diversity that we get with these 4 cloud permitting models while working within the constraints that we all have. So it's a really important topic for us. If you look at the HFIP Strategic Plan, one of the top goals is improving intensity forecast skill. So I want us to think about that one. The second topic, AI models. So I'm not talking about generic AI models. I'm talking about data-driven numerical weather prediction. If you saw some of VJ's slides, what EMC is doing with GraphCast, the ECMWF showed some slides with track skill. The stats themselves were pretty eye-opening in terms of the improvements for these models. So I think we really need to talk about the role that these data-driven models are going to play. And perhaps they're part of the solution to the first thing I brought up. So that's number 2. Number 3, research to operations. I think you heard Pablo and I both talking a little bit about this. I feel like we really need to begin folding in the transition details, every detail possible about how something will go to operations at the very beginning of a project, at the proposal stage, really, factoring in resources needed, funding needed, and exactly what's going to happen operationally at the very beginning. So with that, I'm gonna stop and see who wants to talk about any of those 3 topics. But first, Hurricane Center colleagues, anything you guys want to add? I tried to distill things into 3 points, but obviously there are more than 3. Got some thumbs up from Pablo. All right, well, raise your hand throughout. With that, I'm going to open it up, and it looks like VJ's got the first word here.
All right, Vijay here, EMC. I'm partly speaking on behalf of EMC for at least the first 2 topics. And also probably will touch base on R2, but at a later time. The HWRF and HMON, they are currently in a no man's land. Nobody is supporting them. They are on an autopilot. If something goes wrong, there is no support. And only 3 storms can be run with those 2 configurations. So it's already in a limited capacity. And as probably all are aware of, we had an agreement that they will be retired last year. Didn't happen this year, and hopefully it's not going to happen. We will continue running them in 2025 season as well. And I think NCO has agreed to do that. That's good news. So you will not have a short-term disruption of the four model solution that you have. The real challenge is what happens after 25. And probably we have enough time to discuss about that in the future, but we cannot ignore the fact that by end of 2025, if we don't have a future solution that addresses those issues that you've just mentioned, Wallace, I think we have to really rethink our strategies. And the first and foremost, obviously, is to improve the HAFS performance and bring the diversity that is needed to accommodate the four model solution into a two model solution. You know, we already have HAFS A and B, and potentially HAFS C will address this problem. I don't know. I'm just throwing it up here as an option that should be on the table. But requesting HFOF HMON beyond 2025 would require people to port it to the new machines, and there are so many overheads that need to be handled. So I think we should not be going in that direction.
Yeah, just to be clear, I am not going in that direction. We understand the constraints. What I am asking is that we as a community get creative about how we can keep the benefits that we see right now with the diversity, while working under the constraints that you just mentioned. To totally understand.
Yeah, along that same line, you already answered my question. So in the sense of the fact that we are in a very unique situation because we are having those four models, particularly because we are rebuilding and replacing our software, and we want to make sure that from a strategy perspective, we don't undo what we try to do with having more resources for a smaller number of models that we can develop faster that way. And so I would want to point out that if you work with a more UFS style code base, that you can create diversity in your models by just changing small parts of the selection in all your software, rather than having to have complete copies of software. So the UFS approach allows us to do more diversity with much less work and much less maintenance. And then my question to you is, we're talking also about a HAFS ensemble, starting to build that. What are your thoughts? Would that be potentially mitigating the issue of losing the two, or what do you think?
Absolutely, that could be part of the solution. Yeah, in fact, some of the results that Jai showed yesterday with the improvements of the ensemble in terms of diversity from 23 to 24 look very promising. Ultimately, what we just don't want to see a step function down in skill when we lose HWRF and HMON, and all the things that have been mentioned are, to me, are options for that strategy that we can build together. Yeah.
Yeah, if anyone else wants to talk about HWOF HMON, I'll be switching to the second topic.
Just to close out, I mean, you know what I'm going to say, but I think we have some options on the table that we should explore in the near term to bring that diversity back. And so, let's explore them, and let's see what, how soon that can become operationally feasible. I mean, the multi-storm results they sort of speak for themselves, 10% improvements, and that's without really much attention to the initialization issues and all that yet that are plaguing all the HAFs. So I think there are some options on the table. That would be one of them that we need to explore as soon as possible.
Absolutely. I think we're all on the same page here. We just need to work together to make it happen.
I want to get some inputs from Franklin too. Talking about diverse.
Sorry. Hey, Philippe, do you want to say what you wrote?
Sure. So what I'd say is, in a perfect world, it'd really be a case where we'd be transitioning the current suite of model guidance that we get that's hurricane resolving, HAFS A, B, HWRF, HMON, towards working towards having an ensemble data set that captures that rich diversity through like either, 15, 20, or even 30 member ensemble that's able to kind of give you the correct air spread relationship. Some of the results that we're seeing from the HWRF ensemble being run in the cloud is really promising. But my question is, when is it going to be possible to have such a data set become operational within NSUP? And how are we going to be able to bridge the gap between currently our, for individual model solution from deterministic guidance to having this ensemble data set available for us for forecasters.
Does anyone want to take that question or
Aaron
just
may be
leave it
able
up?
to be the best person because you guys have been running, I mean, you started the ensembles on cloud and you can tell how much of resources is being used.
Let me correct one thing on that. EMC and DRSA started the ensemble.
No. But
I just argued with CIO to get cloud. That's all. I'm just a thorn in their side. You guys are the experts. But I will say that, yeah, that's something we'd love to do. And I'm sure Kevin will talk way better about it than I will.
I don't know about that, but no, I mean, there's probably a lot of coordination and planning that needs to be done to find out, carve out the pathway to get that into operations and accelerate it. It's going to take resources. We need to make sure that, like, is it going to stay in the cloud? Is it going to go to some on-prem? Is the WCOS upgrade have, do we have enough resources to even run an ensemble on-prem? Probably not. So we've got to answer those questions, I think, and put some effort behind it. And we probably maybe only able to do it with a supplemental. So.
Sorry, Henrik, just want to add real quick to what Kevin said. These are conversations that I've been trying to have with people. They are things that have been mentioned in the HEOB. And they're actually conversations that I've had with Frank Indiviglio about potential locations. Part of it is NOAA needs to make guidance decisions and resources available if they want us to do it on the cloud, or set aside somewhere where we can run it in an on-prem, whether that be a developmental system with an operational, like, kind of reverse sandbox, or whether that be WCOS 3 or what have you, having space.
I know a lot of people know this, but just for completeness, it's not just compute cost. It is not just compute cost. If you want HAFS A, HAFS B, H4 and HMON, you either need to cut the teams that implement these things in half, or you need to double the size of the team doing hurricane modeling at EMC. I don't see, no, he doesn't have a very fat wallet right now. So I don't see us making the team twice as big. And so if we are complaining about how long it takes to do R2O, what do you think is going to happen if you cut the team in half? It's going to go slower even. So it's not only the compute cost. It is the team cost, it's the manpower cost, it's the human resource cost, which is the reason why we prefer to have a diverged HAFS rather than having HAFS and HMON and H1.
That brings back to, yes, we want to have a diverse HAFS based on its current core, but that there is a lot beyond the ensembles. For example, physics ensembles. I don't think the pathway that you have will permit using multiple physics schemes, if I'm right, and we need to develop with one physics schemes. How do you build in the diversity other than the initial conditions? Any?
Before I address your question, I think ultimately it looks like we should use a hurricane ensemble. That's ideally in the future. But right now, the big question is the storms cannot cross the boundary. If that can cross boundary, we can make a unification even for GIFs, GFS. I think that should be a big picture in the future. If you have to run a HAFS ensemble, independently GFS GIFs ensemble, I don't think we have the computing and capacity. So the critical, the science development, we need have someone working to move the storms across the boundaries. To address your Kuba's question, we can set up many different physics suites. But if you have to also ask, say, each member also have to have the best performance. That's also a big ask, because we then have to different independent team to work on different physics suite to make each suite have the best performance. If you are talking to ensemble, like our festival, you cannot also say, hi, I need to look at individual members, also look at the ensemble forecasts. There's a trade-off. I just want to make a point there. Of course, we definitely can set up many different physics suite, but make each suite has its best performance. We need to have more people to work on it.
Do we maybe move on to one of the next questions? We're already 15 minutes in. What was your second question again, Wallace?
Wasn't really a question. It was, I was just saying the statistics we saw from the European Center, from EMC's efforts with GraphCast, pretty eye-opening in terms of track skill. So how do we think about moving these efforts from the fringe to more core of how we do things?
So this is Vijay trying to respond to that in a slightly different way than what you asked. So these AI models, they're not cheap, they're not expensive either, but the technology is changing rapidly. The efforts that have gone in to use our own initial conditions, that was the one that you saw. We don't need to depend on ERA 5 as much as we should. But still, the results are really very encouraging. The point I wanted to bring up is we can generate 1,000 ensembles on a single GPU node in less than 10 minutes for a 7-day forecast. Is NHC ready to take advantage of that kind of an influx of data? Or is that the direction that we need to take? Because these models are not physical models. I mean, they have some physical basis, but I don't think they'll explain everything that you need to know other than giving you the track forecast based on a limited training of variables that are currently being used. And intensity, I don't think any of the global models have shown any skill. So that's a different, so without intensity and structure information, is the track information still useful? I hope the answer is yes, but the point is how far we need to go in that direction where we need to think of a T2O of these models.
Yeah, I'll just say that improving the track forecast, I think, is the #1 goal in the strategic plan. So yes, very important. To the extent, do we need 1,000 members? Probably not 1,000 members, but
999.
But yeah, I mean, I don't know. I've been impressed at what I've seen, and that's with a really small effort. I shouldn't say small effort, period, but reasonably small effort from us as a community. And so, how do we leverage that? And it kind of goes back to my first point about losing some of the regional models. I know we're talking about track, but track is a big piece of it. So yeah,
one thing I think is worth adding to that is that a lot of these AI models were just proof of concept trained off of minimizing root mean square error of 500 millibar heights and sea level pressure. So maybe it's not surprising that they do well for track, but at some point we could add in additional metrics by which we're training them upon to, optimize for intensity or structure. So, since it's such a brand new area, we don't know where we'll be in 5 years for sure.
I'm not saying it's going to solve everything, but the initial results to me are worth a little further exploration.
So to continue this thought, one thing I wanted to point out is that the rate of progress of AI is really quite big. So my PhD was mostly on kind of bringing insights from physics to AI, but I was very close to like the computer vision community, the robotics community, and things like this. And I could see it in the matter of 5 years that the field was moved completely to AI. In the case of computer vision, in the case of robotics or like self-driving, things like this, it's tougher because when you get to the real world, you want certain kind of guarantees. You want to understand what's going on. But still, even in robotics, the impact of AI in robotics has been massive. And it's not all AI, and I don't think it's going to be full AI, but we need to know how to integrate AI into our systems, because it really is like I was talking with Mark and Maria a couple hours ago, and he was telling me something like with AI for cyclone forecasting, it feels we're moving not at the scale of years, but at the scale of months. And working on it, it does feel like this way. And the second point I wanted to make is one thing I realized on this conference that I didn't see before is like there's lots and lots of ideas and lots of progress, and like there's lots of plots that show like 5% improvements or 10% improvements, very nice improvements on track or intensity, given different ideas. There's many beautiful ideas on like the moving nests or like different data simulations. The one thing that I feel, and I could be wrong because I'm very new to this, is like the integration is very hard, both logistically, but even like modeling wise. And one thing that AI may bring an opportunity on the scale of 5-10 years is being like this glue that allows you to bring different improvements so that 5% improvement and another 5% improvement bring a 9% improvement, not like a 1% improvement because these two changes didn't know about each other. And we've seen this internally where if we make a small mistake, AI just corrects for this. And it makes things much easier to bring together. And I think that's an opportunity for this field that will make your lives much easier as well.
And I was going to say, we're seeing from a lot of different AI groups that they're doing things to train specifically towards tropical cyclones in different models. So things are still evolving very quickly where they're going from, say, those initial training mechanisms of looking at 500 millibar heights and whatnot, RMSEs, to much more specific training methods. Several of them have come out in the archive papers and whatnot so far. But also, we think that there are ways to address parameters other than track, even through the existing models, getting into some of the statistical post-processing, bias corrections, and other methodologies that we used to use on the global models when they were much better with track than intensity or anything else, which you could argue is still the case. However, it's not nearly so much as it was a decade ago or so. We're just seeing these improvements on a much faster time scale than we did for the global models coming in.
This one, from EMC. So follow what Vijay mentioned earlier about the AI models, the intensity very weak. There are ideas, it's hybrid approach, use the machine learning model to predict the notch scale and the notching to the physical model, to maintain also the good track and also the hurricane intensity. That's a we actually started in the community, and we are still falling behind. If we really want to catch up, we should act now.
You may have just said, I didn't quite understand you, but an idea that has been rattling around in my mind that I talked to Wallace about is, say you have 1,000-member AI ensemble for track. A pretty straightforward way to get some intensity out of that is to run 1,000 instances of ships and LGM off those tracks, right? Somebody should try it. I bet you might get some good results. We talked to Daryl about this, and it's pretty straightforward to get the outputs needed for ships and LGM from these AI models. You just add some output parameters, right? So this might be a quick way to juice some decent intensity forecasts that we're not getting out of these AI models right now.
I guess the quick note there is we're already working on it.
That's how awesome it is.
Can we use the final 6 minutes to adjust the R2O question? I don't know who wants to get started. Chandra has his hand up.
So this is Chandra, JTTI Program Manager. So based on my experience with JTTI, so the target has been changing ever since I started JTTI. For example, initially I funded a lot of projects to HARI. HARI is gone, it was never operationalized, okay? And then we came up with RRFS. So funded a lot of projects with RRFS, with FE3 base. Even before RRFS V1 became operational, we are already changing the DICO to MPAS. In fact, in a 2-year project, who proposed to use FE3 Middle of the project, I have to advise them, go and use MPAS. So to your question, at the time of proposal, if you want to say where it is going, with the changing moving target, I mean, these are a few examples. I have seen it other issues with like a data assimilation system. Some people have funded the DOT. At that time, we haven't even decided what our data assimilation system is going to be. And then we decided the GSI and then the JEDI. So with the moving target, we always have the moving target. It's changing like every 2-3 years. How can a PI come up with something at the time of proposal where the output is going to be? That is extremely difficult. I mean, that's what my experience. I'm just telling, and I'm seeing a lot of facing a lot of challenges when I try to develop the transition plan, because maybe you're right. You are one of the best USC we had, very cooperative, and we are able to do the transition plans. But for other programs, other centers, we get a lot of pushback. No, we don't know what we can transition. I can't give any budget numbers because I don't know how the end product going to be. Okay, so it's going to be extremely difficult. That's what I want to say. But a very good idea. Though. In fact, I included that in my notice of finding opportunities. PI to come up with the target system. Receiving office and then target. But I face a lot of challenges with that. Yeah.
It's going to be really hard. The only thing I'll say is I think that right now we treat these projects as unidirectional. Like they start and they're going to end somewhere, and we don't iterate with each other enough. So we as the end users, I think, sometimes don't iterate with the researchers enough, and then sometimes the researchers don't come to us enough to get requirements. So I would like to see us work more toward a more iterative process than we have now. And it's not, no one's at fault, really. We just both need to do better together.
Let's let Gopal speak, and then maybe Pablo, and then.
Yeah, I wanted to continue on what Chandra said. If you're really seeing, the credit goes to HFIP too, because this is a machine which involves forecasters directly, and we know what our target is: 50% improvement on track intensity, and we are going into structure. If you have seen in the last 15 years, how many models have we changed? We are not even moved from it. Still, we are using HBAR from HMON because forecasters want to get the best value. We don't want to throw models after models wherein it doesn't give a good prediction. So as far as a model goes for a year, unless it's well tested for several years, it doesn't get changed overnight. That's one of the answers I could give you.
I'm glad you bring in back the history because we were running the GFDL and the HFIP side by side for a damn decade because we didn't have a smart way of actually making the choice to know we are going to stop one and put all the effort in the other one. So, but I think, Jisun, you have to say something like 7 times before people hear it. I've only 4 times said this so far, this conference. We're doing things technically pretty decently. We're making progress. But the thing that makes R2O slow is our end users being risk adverse. And so, unfortunately, I have to go to the airport pretty soon. Sorry, Jisun. But I think in the next hour, if we talk about some of the things with the social science, this is where we really need to focus on. We need to figure out ways of being more agile in terms of taking a little bit more risk, perhaps, or other ways of ensuring our end users are willing for us to change quicker. And I'm not saying that this is the solution, just thinking out of the box a little bit. If we are moving a lot of our development work to the cloud, and by law, we have to have a primary and a backup machine. What if we did things a little bit more similar to the European Center and have 1 or 2 full suite parallels running that we can continuously tinker with? Perhaps that is something that we can do to convince our end users that we don't have to do another 3 or 5 years of retrospectives. And so that was 5 times. We need to deal with the risk aversion of our end users if we want to make this process quicker. That was 6 times. Jisun, can you do the 7th time for me the next time?
Yeah. Pablo, you want to say your comment now? As we bring it to a close.
Okay. Well, we're out of time. I just keep it short, building on what has already said. All I can say is I'm going to sound like a broken record, but going forward, we're going to pay more attention to, proposals that are proposing to do something for NSC, that we work out those details out of the gate, and that there is better follow-up along the way, as well as has said. It is paramount that we address this issue, so we can address this problem we have. We have a lot of good work going out there, but only a fraction ends up making it to the front of the forecast. And now I'm not oblivious. I also know that NEC has a responsibility here too on the forecasting side, to iterate more with the researchers and providing feedback. That's really, really important. But it's something that we're definitely going to be paying more attention going forwards. At the end of the day, in my view, a proposer is proposing to develop something for NSC should not go forward without NSC, having a good look at it. And that's something that we certainly are looking into improving and trying to put something in place that better allows to track that. So in any case, it's late Friday, so.
All right, thank you, Pablo. And thanks again, Wallace, who didn't even know this morning that he was going to be facilitating this. So we appreciate it. Round of applause. All right, so for our next session, we're going to have Jisun Lee and Andy Foster facilitating a joint session on SBES and IDSS. So I don't know, Jisun, if you want.
Yes, I'm here. I'm going to take a page out of Wallace's book. There's too many slides. You've been seeing slides for 4 days. So I just thought we could just have a conversation and sort of talk a little bit about the work that we do in social science. As Hendrik says, I think a lot of the work that we do is around understanding people and places, and how they're going to behave, what they think, and how they're going to potentially behave and react to a lot of the work that you all do. I saw a lot of similarities these past 4 days in the work that you do and the work that we do as well. We develop models as well. We're working on an agent-based model that looks at how people make decisions about particular weather events. For us, it's flooding based on the supplemental work that we have. So we're trying to model how people could potentially behave during a flooding event, right? And it's extremely difficult, and we don't have as much data as you all have. And so you're decades kind of ahead of us in this sphere, but we're trying to develop some of those models as well. We're also trying to develop some economic consequence models, right? Of what are the impacts on the economy, on particular industries and sectors, based on some of these weather events. And I think what I really kind of came away with these last 4 days is you guys are a very close-knit group of folks, and you have a very particular vocabulary that you all speak to yourselves about. I think I understood maybe 50%, if I'm giving myself some high marks on that. And part of this is, I think we need to develop a shared vocabulary in which we as researchers in the social science arena and you in the modeling space can be able to speak to each other so that we can co-create research questions that actually get to some of the outcomes that you guys are looking for. And so when we talk about end users, as Hendrik said, right, he's on the risk aversion side, so 7 times said. The idea of being able to define exactly who your end users are and what you need, I think is going to be very important, and something I think that we can kind of share together. So I have 2 questions. The first one being, and I say this a bit of a challenge, and so I want you guys to kind of challenge me on this. The improvements that need to be made to the model for me is fundamentally a social science question. And I don't know if you all agree with that or not. Let me say that again. The improvements that you need to make to your models, to me, is fundamentally a social science research question. And I say that given the other end of the spectrum from what Wallace is talking about. So he's talking about the transition space. I'm talking about the requirement space, right? Because the improvements that should be made should be based on what your end users actually need. Those are the priorities that we talk about. You know, when Wallace had that giant funnel with all that stuff going in, like that's a lot. And the only way in sort of the universe that we kind of live in now, and I'm talking about our resource constraint universe, we've got to limit what goes in the top of that funnel too, right? And the only way for us to be able to prioritize what is really important for us to do, to me, is a social science question, right? Because we need to better understand who those end users are. So how do we, so my second question being, so how do we create a space together, right? Where we develop shared vocabulary, where we're co-creating with each other what the research question should be, so that the ultimate focus is always on the end goal, which is the outcome that we want for our public, right? Which is faster evacuations, which is people getting out of the way, you know, people having plans and mitigation activities to make sure that they're not as impacted by that. Because right now, I think you guys are off here doing your modeling, all of the science and the research that you're doing. We're over here doing our stuff. But we've got to find this middle ground somehow, of where we're doing this together, right? And how do we do that? Because I've been kind of racking my brain. Yes, please, Stanley.
Yeah, I agree and disagree. Social science is a big area for me with this, and going back to Dr. Neil Frank from many decades ago, he made this statement. He said, if we would create, can you hear me okay, by the way?
Yes,
okay.
We can.
If we would create absolutely perfect forecast, there's still a problem with people responding the right way. And it's absolutely true. The forecasts for Helene were phenomenal, but people didn't understand the full picture. I would say, I would take what you said and twist it another way. The foundation of getting this stuff to the end user are accurate, more accurate, improved forecasts, understanding the uncertainties. But then the end user thing, it's understanding the complexity of the hurricane problem, which many of us do, and getting that to the public, understanding floodings, tornadoes, etc., the uncertainties, everything like that. But the foundation has to be the best forecast we can possibly put out. And I'm sure anybody from any forecaster would agree, they're constantly dealing with social science because they're trying to articulate their forecast, their key messages in a way that communicates to the public. And of course, they can improve on that as well. So hopefully that makes sense.
Jisun says it makes sense. So Jisun, to sort of try to translate and develop a common vocabulary. Even now, we're still talking a little bit in our range of comfort because we are, I mean, Ellen Murphy, 1993, I don't know, is that the one that Stan, you were mentioning, but what makes a good forecast? His statement was there's no value in the forecast, there's only value in the decisions people make. And we are getting better at that, but we are only right now only talking almost from the physical science side about how the fantastic work we're doing translates to people's discussion. But there are other overlaps in social science and physical science. For instance, if I work, and then I'll make it a little bit easy to get outside of the hurricane side, but just to give you an example. We as scientists like to work on projects where we think we can make progress and where we can publish papers, which is a very natural, good thing to do. This is not a critique. But that means that if you look at seasonal forecast, there are a lot of people who really like to see if they can get a few more % out of the NGO, out of the El Nino forecast. If you look at it from a user perspective, and an end user perspective, there is probably more value in us actually putting our money in MGO, because that is a piece of the potential forecast or the predictability that we haven't really explored yet. So how do you translate that between social science and physical science? We in the physical science very rarely discuss what is good enough and what is really needed. And that would be one of those places where I think between social and physical science, we can accelerate the benefit that we provide to the American public and the world public if we have that discussion a little bit more and have our joint vocabulary developed there. So,
Yeah, Stanley, did you have your hand up again? Did you want to respond?
Well, I did, and then I changed my mind. But since you mentioned it, I'll just say that as far as communication with the public, again, we have to go from a foundation of the best forecast and best product we can possibly do. But yeah, the communication on all levels, how to get through. I remember when Jerry Jarrell in what was it? It was Hurricane George in 1998, and he was trying to get people in the Florida Keys to evacuate and to understand the seriousness of this. And he got exasperated. Finally, he started showing pictures of Hurricane Betsy totally overflooding the island. So they had the forecast. They knew it was going to go through. They didn't know the exact intensity, but they had to get people ready for the worst. And sometimes pithy statements, short little things. We can't bother them with all the complexities of what we know. They want the bottom line, but we've got to start with that knowledge. So that's all.
No, and I wouldn't disagree with that either. So what I'm trying to say is that instead of us thinking in sort of a linear production process, right, where it's like you guys work on the science, then you kind of hand it off to me to figure out how to say it, right? Like, why could we think about a more iterative process in which we're working together with a common end goal, which is, saving lives, protecting property, enhancing the national economy, and then together, I think we need to iterate on what is good science, what is the best, or as Hendrik said, what's good enough, and then how do we actually communicate that in the production, in the products that are developed, right? And because a lot of the people, like even NCEP, the WFOs, these are all of your end users too, right? In addition to the public, in addition to core partners, right? I think similarly, we are in this research space, where our end users are internal as well as external. So how do we think about developing products with the science together from the beginning? Because it takes all of the science that you guys have, but it takes all of the science that I have too about where people live, what they think, how they behave. Some of the demographic work that, Dr. Elizabeth Gregg and Laramie and all of them talked about. We've got to bring all of that data together and develop a product that makes sense from the beginning, not at the end. It's not my job to translate your science. It should be our job together to figure out what that product looks like that incorporates both of our sciences that make the most sense to people. Does that make sense? Does anybody disagree?
I think you're being
Stan, we may have lost you. I don't have an answer to your question. I think it's a great point. I just wanted to also point out that we're sort of dancing around this, but I mean, a lot of times people are getting these forecasts from the models without going directly through the National Hurricane Center. I know we want them to, right? But people are sharing these things on social media and they're seeing raw outputs from HAFS, and it's going to impact the way they're making decisions. So I think that lends even more support to why this needs to be done really from the beginning or within the entire process rather than just at the end. So just wanted to make that point.
I just wanted to say that I share G-Sun's, what I would like to say is frustration. On my part, it's frustration. I mean, I feel like I gave a similar appeal a few years ago here, and it didn't really go anywhere. I think that from within the Weather Act says that we're supposed to have a project for hurricanes that also discusses risk, assessment, like personal risk assessment. I think the original language was something about from specific to storm surge, but it's become more broad since then at the reassessment of the Weather Act. And I think Jisun's right. We're not going to make progress on getting people to act if we're separating everything by the modeling and improving the forecast and a separate thing that has to do with messaging. There needs to be interconnectivity between these groups, and I don't think it's happening. I mean, I was here in the room for 2 days and 1 day online, and I'm frustrated, to be honest. I mean, it just seems like we put a lot of money into modeling, and we want to have a perfect forecast, and but just like Stan said, we're not going to get people to act if we don't assess how people react to that as well. There's ways that what about the display of the information? What about the R2O part is really not happening the way it should. And I just wanted to, say that, I sense the same frustration. So I just wanted to express that.
I think one way we could become a little more integrated, I mean, we all of us scientists work under the assumption that if we improve the track, the intensity, the structure, forecast, that is going to help people do what they need to do more effectively. It'd be helpful to know if that is the right assumption? And is, working on, I'm about to offend somebody, but is working on drop size distribution in the microphysics scheme the best way to attack whatever the answer to my first question was? Like, if we can kind of answer all those questions together, I feel like that's going to get us to where we need to go, but we're not integrated enough. You're right.
I just kind of have an add-on, perhaps a little bit provocative to what you just said, but what if, so we have these goals for VBACs. What if the most impactful way to evoke a response from the public is not to improve VMAX by 10%, but it's to improve something else by 10%, right? I don't know what that something else is, or what it looks like, but that's just a provocative thought that I think kind of maps on to what you guys are trying to say, like in terms of a physical improvement in the model, right? That what has and has not been explored in terms of what improvements in the model map into a public response.
Thank you. For those who don't know, my name is Jason Anderson. I work with OST on modeling. Before I joined the team 15 months ago, I had about a 17-year career in commercial weather, and a lot of this conversation has really gotten my brain going. Two things. A former client of mine, Florida Power and Light, they know the National Weather Service, they know NHC, they know how to access what we're doing. They pay commercial weather because they need someone to translate what we're doing in this room into an actionable decision. And that decision flows through multiple levels of an organization, all the way from headquarters down to individual districts to the individual substations. And you can expand that out in multiple areas to multiple clients to multiple use cases. The modeling is amazing, but they don't reach out to us here at NHC, NWS National Centers, because they don't know how to reach us, and they don't think that we understand what they care about. That's what really commercial weather does, is they translate and make an actual decision. We need to find a way to get to those people more. I know we have those relationships, but we really need to, as you said, Jisun, find a shared vocabulary where we're actually talking to them and not at them. And same thing, we talk about end users in here. I think about NHC. Well, NHC is an end user, but the National Centers is a user. A WFO is a user. Are we even talking about the same end users, EMs, entities, infrastructure? I think we need to think in that term of, okay, who's the end user, but also how do we translate the amazing work and the amazing science and research into, as we've all been saying these last 4 days, into a decision. And everything I thought about commercial weather is actionable decisions. That's what I was paid to do. Translate weather to an actionable decision to have some impact. I know that's just something I wanted to share with the room as this conversation goes on.
And so in terms of talking to the commercial sector, that does need a legal framework, and we have been pretty successful in the last year or two to set up a bunch of creators with a few smaller modeling companies at least. And so we are starting to build the foundation for being able to do that technically and legally. And so we can, once that is set up, it should not be that hard to put social science in that part too.
I just had one little piece to that. That's a great thing to do, but I don't know if we need to go through the commercial entities to do that ourselves. We have these relationships already. I think we should grow them more naturally and organically. You know, we had our friend from Google here. We had someone from Royal Caribbean last year. You know, we've got this little, we're starting to touch it. I think we need to make an initiative. I don't know if that's a work group or something where we go out there and start getting in the room with these people and talk to them one-on-one.
In slightly disagreeing with you there, the fact that there is a FACA law makes it such that we have to be a little careful with how the government interacts with that. And so from that perspective, just for making sure that I don't get fired for something I don't want to get fired for, I prefer to put traders in place and make them really generic in what you write, that you have the legal framework then to talk to each other, which you don't have if you're not in a FACA position or something else.
Oh, no, not at all. Dave, did you have something you wanted to add?
Yeah, I just wanted to say that just coming from the private sector and working for the last 35 years with NOAA and NASA as partners, and going down the whole road of, you know, what's the Weather Service's job versus what's the private sector's job. You know, that's why you have a private sector, to value add to what government information is out there. And, you know, the private sector does a great job, but I do see, you know, the Weather Service making pretty strong inroads in the emergency management area. You know, Ken Graham has said multiple times, I'd like to have a forecaster in every emergency operations center across the country. And that seems a little bit of a stretch to be able to accomplish that with the manpower resources that are out there. But you know, the Hurricane Center is doing a better job each and every year looking at things to, you know, how can they better communicate? But it takes a total partnership of private sector and NOAA and the Weather Service to deliver the messages that are going to make people listen. And I don't think any one of us can do it by ourselves. And I always hear the Weather Service saying we can't do it alone. So we definitely want to have NOAA as a partner. Thanks.
Yeah, thanks, Dave. One thing I'd like to add, and you know, addressing some of Ji-sun's points and also Jess's point was, you know, I was leading this, bringing a lot of us together to discuss this new strategic plan, and I think one of the things we identified fairly early on in the process is that the last several strategic plans, they all have a table of quantifiable metrics of measuring success 5 years down the line. And, you know, those metrics have always focused on such and such improvement in track and improvement in intensity. And one of the things that we were really pushing for this time, and thanks for your involvement, Ji-sun, and was trying to come up with some metrics by which we can more directly address, you know, society and the response to our forecast, rather than just measuring some incremental improvement in the cone or the intensity. And I think that was a big challenge, to especially to the scientists who are mostly working with NWP. It's hard for us to even understand, well, what can we measure? And, you know, by how much could we conceivably improve? Like if we're talking about, you know, improving people's responses to warnings, or improving the lead time at which people evacuate. Obviously, these are sometimes difficult to measure, and it's difficult to know how something in the forecast, you know, will translate to that. So I think we're making some progress, but it's definitely a challenge for us, and yet keeping that communication open between the scientists who work with the models and the observations, and you know, those with more understanding of the social science. It's an important first step. Her hand up.
So for a lot of the developer groups, they may not have the correct contacts for the social science side, because it's a very, I mean, it's incredibly broad, and finding the correct specialists can certainly be a challenge. What about something on NOAA's side where it's part of the transition planning process at the beginning of projects, where it's not just coordinating with the HOT or the relevant test bed, but also coordinating with a NOAA-sided social science specialist on what might be needed? Because at least for some of these projects, it's invisible. It's behind the hood. There's no end product of it. But for others, it becomes very important. There's been a lot of work with the changes to the wind speed probabilities and, you know, the impacts on a wide variety of users with those. But for others where, you know, we're testing a new predictor in ships, you know, nobody ever sees that beyond a chart we might show at one of these. It's like, yes, we have a 0.5% improvement in ships forecasts. But nothing actually comes of that. But actually looking at these projects from the get-go and what is the end goals here, and is there a need to really assess how this is being presented to end users right from the beginning, and make that part of the transition planning at the beginning.
I'm just waiting my chance. You go right ahead.
No problem. Kevin Garrett with STI. So yeah, really enjoying the discussion. I agree with a lot of what's been said, and probably could talk about this for the rest of the evening. So this gets back to kind of what I gave an overview of on the first day, and saying, like, we say all these projects need transition plans. There's one project, right? One master project, and that's HFIP. And we need to do a better job of connecting all the different elements across that whole value chain. So at the extreme far right is outcomes, right? And we need to understand what outcomes are we looking for, where are the gaps, why are people not getting the message, and how much of that can we control? What do we need to do to enable that? That's where social science comes in. So maybe just picking out two pieces of that value chain in terms of developing models and making improvements to the forecast, whatever metrics, track intensity, storm size, and social science. They have to be linked. There has to be some synergy there. What we're doing and prioritizing on the modeling improvement side needs to link in to the social science side. So hopefully, I don't know how to do it. Everybody hates writing project plans, you know, having this overhead and burden and stuff, but we need to figure out a way to create that space so we're on the same page and we're in sync across the whole value chain.
I just want to add one thing to what Kevin said, since I kind of answered to him. It ties to all of that. Is right now, in the way HFIP is structured, there is not funding for anything pretty much other than modeling. So of course we are modeling centric at the moment, despite trying to bring the community together and keep things going. That is a huge hurdle at the moment. With GSUN's group being stood up in STI, it gives us a space we can walk into more easily, but it doesn't mean that the work is just going to be handed over to all of us. So we have to do our part, which is why I had this session here with her and with Andy that hasn't gotten a chance to talk yet about the IDSS aspects, which are tying our science to her science that really is a shared science. And the, you know, it's going to be hard. It's not what we're used to. It's stepping out, especially for those of us that are from the Met side. It's stepping out of our comfort zone of what we know. And that is, if we make a great forecast, things will be wonderful. But obviously that's not the case. They might be better every time, but they're not, you know, the perfect idea of the world. So anyway, Andy, go ahead.
Thank you. No, it's been a great discussion. I didn't want to interrupt it. And Jason and I talked a lot, and what we do is very interrelated in terms of social science and then IDSS. impact decision support services. And I don't know how familiar you are with that term, hopefully very familiar. But when we talk about how tangible the work you're doing, how important it is directly related to how we message and support those we serve, whether it's a core partner, an emergency manager, or the general public, or the TV personality, whoever it may be. We're supporting them with information. So my question, I had a bunch of slides, but I got brave after Wallace and just put my questions on a napkin. So I'm not going to show slides here. But what is the ultimate outcome? What is the ultimate outcome of your work? And let me say, this is the first time I've been part of your group here. I am thoroughly impressed. I've seen more equations this week than I've seen in a long time. But from a research community, from computer modeling, what is the ultimate outcome of what you're doing? Anybody want to answer that? See a hand or two.
I'll add, I mean, I think it's unfortunately pretty narrow in the sense from my perspective, this is Gus at HRD, is the way I tend to think about it, and I need to change my thinking is really what do the operators need at NHC, right? And that is a big part of it, right? But it's not the total part of it. It's not everything, right? And I think how do we sort of change our mindset to think more broadly about how this work can impact, you know, the broader community beyond just folks at NHC. No offense, Wallace and everyone online, you guys are great, but I mean, how do we get there, right? And I think part of that is, as Aaron mentioned, is in a resource constrained environment, we sort of have to pick our lane a little bit. And I'm not saying that's the right choice or the optimal choice, but yeah, I think to echo what you're saying, how do we challenge ourselves to think more broadly about how this work impacts?
Ask you the right questions, right? Get the right answers. Yeah, so another hand or two maybe over here. Ultimate outcome.
I'll say there's multiple. I mean, the answer to that's going to depend on the person you ask, even within this room.
Mm-hmm.
But a lot of people are going to say, oh no, I want to understand physics better.
Mm-hmm.
You know, that's my ultimate outcome or something, you know, for someone. For me, it's, you know, producing better predictions. So doing that by providing better guidance for the forecasters to produce better predictions.
Right.
But, you know, again, that's going to vary by individual here. And in the broader community as well, just within the modeling community, because there's a lot of people that it's like, I don't care about the forecast. I just want, you know, the best microphysics package that I can develop. Or, you know, I want to understand the vorticity dynamics, you know, within a hurricane, or even how can I apply this to a galaxy interaction? There's a lot of different answers.
There are. And it always, from our perspective, looks a little different, doesn't it? I worked operational forecasting most of my career, issuing warnings and forecast. What did I depend on? Modeling, your research. I needed that to have a message to interpret, then to serve a core partner or the general public who had a different question and a different need, right? The ultimate was to provide them with critical information they could understand and put into action. That ultimately was the purpose for what it was to be a forecaster, but using your expertise and your modeling to make that happen. Totally depend upon that. I see maybe a couple of hands there on the online. We got, I'm not sure who came first. Go, Dave.
Yeah, I think the ultimate goal shared by everybody is to save lives and protect property.
That's our mission, Dave. Absolutely. And by the way, you may notice too, the last let me get away from the speaker. The last year or two, that decision support services, probably about 2 or 3 years now, decision support services was added to our mission statement. So in addition to saving lives and protecting property, also providing IDSS. That is our mission. Stan?
Let me get real here. Picture a automobile factory, and you have managers and you have owners and you have all sorts of people. if I'm working on a particular thing, I'm doing the seats or something like that. Yes, I'm thinking, well, the ultimate goal is I want a good car that people can drive and that they like, so they'll buy and keep me in business. But my goal has to be to make the best seat. And when John Gamache, just to pick on him since he probably isn't online, when he's processing radar data from one of our flights, he's not thinking of the forecast per se. He's not thinking of the person evacuating from their house. He's thinking, I've got to process that data the best I can. When I'm processing drops on data, I have like fear come on me. If I mess it up, it can mess up the model. So I want to put out the best data. And not all of us have to think of that. That's almost for managers and higher ups. Each of us has to do our job. And by the way, I want to throw out something I put in the comments, which is very important. When we talk about communicating with the public, the issue is trust. Who do they trust? And the reason accurate forecasts are important, even in the big goal, is because when there's a bomb and it's not explained and it really messes it up, the public loses some of that trust. And so they have to know who can they trust, who can they turn to. But again, the goal, each of us has to do our part. Cloud microphysics is incredibly important for better intensity forecast. So those persons have to do whatever they can. So I think some of us don't have to look at the whole goal. We have to do our part, our little cog in the wheel accurately to help. So.
Hey, Stan, thank you. It's Aaron, by the way. I don't disagree with you from a compartmentalized stance of what you're saying. Everyone has their component that they care about, that they're good at, that matters to them. But none of us are in a vacuum. It doesn't just run serially from each piece to each piece. We have to be parallel, matrix, whatever you want to call it. All of it does go together. So on a pragmatic level, they have to care. You know, doing, like you said, picking on John, doing the radar, getting the best radar information matters, but that radar information matters because it feeds to another piece either at the same time or downstream. So he has to care about what it's being used for, because otherwise you could say, oh, well, I only need to be 90% accurate instead of 99.6% accurate, things like that. There's not a one-to-one relationship of how I'm trying to explain it, but you have to care. Ultimately, I think all of us got into weather predominantly for the same reason. We want people to be safe. Otherwise we wouldn't be at the Weather Service. We'd be somewhere else at an insurance company making money off the weather, or an investment bank, something like that. But anyway, I get where you're coming from. Sorry, Jason.
Well, let me respond to that quickly. Stan HRD, since I should have announced myself before. Not everybody works that way. There's people that have to be compartmentalized to do what they do. Anybody who works with me know I'm kind of ADHD, DDHD, and I can get so big in the big picture that I don't focus on what I need to do for my little part in the whole flow. So we have to kind of, there's a good saying, see globally, act locally. So yeah, we can see globally, but we got to do the act locally.
Yeah, I think Stan, part of the point, when we say we need to think more about the people and the end user, I think we're saying we as a community, but not necessarily every single person in meteorology, because yeah, some of the people working on their little individual project, maybe their attention is best focused on their project.
So to expand on what you're saying, well, and to elaborate, I was just having a conversation with Chaman. I think if we're performing optimally, we're helping people make better decisions based on the hazard present, right? So on average, the hazard present, like for example, Vmax is pretty small, right? But R64 is a heck of a lot bigger, right? We're not really focused on R64. That's a pretty big hazard. It affects a lot of stuff, right? It affects storm surge. It's a pretty well correlated with damage. A lot of stuff happens there, right? And so I think that's a missing piece in all this, is right. We're moving there, but we're still focused on verification of one thing, and at the exclusion of some other stuff. You know, the probabilistic wind forecasts are great, and I hope we continue to move strongly, you know, down that area, down that lane, because I think, you know, people I know that know nothing about, you know, the science really, will make decisions, their own decisions, based on the probability of the wind exceeding some threshold. And that threshold is going to depend on what their need is, right? For some people, it's going to be tropical storm force. For some people, it's going to be 50 knots, right? But you know, if we're giving them good, reliable information on the probability of something happening, and they can make a good decision based on that, I think, you know, that's a big win.
That's a great comment. I was about to ask, what is decision support or decision support services? It's important to at least know what that means, because that's our mission. So we have obviously different roles, responsibilities, and that is already discussed, and we feed that. And there's also, from your perspective, all perspectives, there's a different user group that we're working with. You're supplying incredibly critical information to those internal to the Weather Service, but also those outside. And they're taking what you're doing to interpret that to help them make better decisions, and many times life-saving decisions. And this realm is only expanding as we go into probabilistic information and probabilistic messaging. That's where we're going. That's one of Ken's 10 initiatives, and a part of that team as well. And it really is, okay, how do we equip the forecaster, but also adequately inform in a way they understand that core partner with a range of outcomes or scenarios, and how to pull from that relevant information to their decision making, their thresholds. So ultimately, we're all contributing to that in different ways. Totally agree with that. But ultimately, it's about, am I serving that partner? Am I serving that community with the right information? I see a hand, maybe. I see a thought bubble somewhere out there, maybe.
So John Kaplan, HRD. I think really what anyone wants to know, the impacts where they are. They want to know the wind, the rain, the surge, and what the impacts of those impacts are.
Right.
I get those questions all the time from family, friends, neighbors. How bad is it going to be here? What's, you know, so they say, well, the wind's going to be, but they don't really know, what does a 40-knot wind mean?
Right.
I stress all the time, and this came out in Helene, that, you know, the winds get above 40, 50, stay away from trees. And how many people died from that in Helene? And how many people have died in the last 10 or 15 years from that? Quite a few, actually, probably more than surge. If you added it up, really. So it's like, what are the impacts at a given point? That's what someone wants to know. And what are the impacts of those impacts? And explaining that, you know, that may be a little trickier. What does 4 inches of rain mean?
Right.
In Miami, it doesn't mean the same as, like, I grew up in New York. It's floods a lot easier there. The ground doesn't soak it up. So, and certainly, you know, trees 40, 50 knots up there are going to come down a little easier, but it's the impacts and the impacts of the impacts.
Right. I'm loving this discussion because you're asking the question before I get there. You're asking, that's fantastic. That was actually my next question. What do they need to know? Now that they varies, right? It could be, right, my grandma, my mom, whoever is asking that question, like texting everyone like I did in the last hurricane. Or is it that forecaster sitting in the office, they're looking at that information. They're part of the they that need that information to interpret. But what do they need to know? And what this group is doing is providing that foundational knowledge. Think also in terms of, I call it a continuum of messaging. It really is not about one product or one message. It's about the whole continuum that you provide, from a national center to a regional center down to the local forecast office. And it really is telling a cohesive story with increasing specifics and details based on the partner need as you drill down. Where does that information come from? Well, it starts with a model. And I think about, in a lot of ways, what you are doing is writing that script to this cohesive story. We're starting the script to tell this one story that we're having to tell through, right, the multitudes of people that from all these different questions and decision points we're trying to answer. but you're writing the script for it. And then we're building from that. I think that is an incredible responsibility. But you have to be asking, I think, these kinds of questions where I hear bubbling up. Who are we serving? What do they need to know? Where does a particular kind of message or piece of information fit within this continuum? So, great thoughts. Anything else? I'm just impressed you're here still on a Friday afternoon, so thank you. I'll go back to my napkin if there's no other questions popping up here. How much time do we have left, by the way? Oh, we got a few minutes. Okay, great. So what is really your role then? You've heard this, talked about it. What is your role here? And Jason's kind of brought it up because I want to really leave here probably more questions than we do answers, because I hope we have this ongoing discussion. Do you see your role here? Or maybe the other question is, what questions do we need to be asking? We should go out of here with a set of questions to say, how can we bring this together so we're thinking holistically? What are the questions we should be asking? What do we need to answer?
What do people really want to know?
Okay, that's one. And by the way, we said, I've heard earlier, in terms of relating to our partners and communities, we have an IDSS program. We all do IDSS. Every office does IDSS. Weather Service has been doing IDSS for forever. That's what we do. But part of that is that engagement with the partner community to get that answer, right? So there's a tool out there. You may have heard of NWS Connect. So that's one of the big tools under bill funding, in which that's going to help us collect in one national agency database a core partner profile that will have the answers to some of those questions. What does a particular core partner or core partner sector, what kinds of thresholds or decision points do they have? What impacts them? We can make, as we begin to collect that and hold that, that is where even your community can then really link up with that and draw from that and have services and models that relate to that database to have more tailored information. So we have ways to begin to collect that very question. Any other questions we need to know? What would you need to know to connect all the way through? Anything else? When? Right. And what's interesting about that question is that you think about a continuum of messaging, you also think about a continuum of community or partner engagement. And that can start on a seasonal basis in that prepared, or really that mitigation stage. So that's important information. And then you move along that timeline, you go into maybe the sub-seasonal. You get into, and then maybe 8 to 14 days out, or now you're getting to more the preparedness stage of things. And then you just kind of keep drilling down to the event actually occurs. So you can have a wide range for any given entity or core partner. They're going to want to know different kinds of information throughout that time scale. And the community needs to know that from a preparedness standpoint, all the way to the response and even recovery standpoint. I heard a beep. Stan.
Well, you said something great there as far as early on mitigation. People often ask me, what's the use of the seasonal outlook, which I've been involved with for decades. And because some of us who work on it consider it almost worthless as far as Joe Blow public being able to know about the hurricane threat. But one thing it's very valuable for, it gives a really good press conference because people are interested, and NOAA and the government take advantage of that press conference to share preparedness and mitigation and get people woke up early. And the issue is we don't want to be communicating, 3 days before the storm, 5 days before the storm about a hurricane threat. We want to educate. NHC does a great job. There's a National Hurricane Conference, which they educate media and they work in all sorts of seminars. But to get that information to the public, to continually educate people who maybe want to ignore it until it's 3 days ahead. So yeah, early on, educating.
Yeah, great point, Stan. Anything else?
Can I add something? Yeah, Will Kamarmi, OSTI modeling. Yeah, just one other point along these lines is that I think to some extent people are at least becoming better at understanding probabilities, probabilistic forecasts. There's still plenty of work to go. But you know, a lot of people get a sense in their mind when they hear 70% chance of rain, you know, they'll pack an umbrella. And I think we've also made great strides in terms of people understanding, you know, if a major hurricane is heading their way and you're told to evacuate, you need to do so or you know, you could drown in the storm surge. But yeah, there's still definitely something that we need to work on in terms of people understanding the inland wind gust threat or the flash flood threat when the Weather Service says that this may be, you know, 10% worse than the highest recorded flood in the, you know, mountains near Asheville. And then people don't even know how they're supposed to respond to that. They don't know, okay, well, the flood waters have never reached my home. I assume I'm safe, but they don't actually know that their home is about to wash away. So
Yeah, what does that forecast mean to me, right?
Right,
What kind
exactly.
of context is there to this information?
Right, exactly.
Yeah. Yeah, it's a better job of communicating. It really is about communication. And ultimately, all of this, we're talking about people. It's about human beings who have all kinds of different experiences and the way to interpret information, how to use information, makes it pretty complex, obviously. I see a hand.
Yeah, I wanted to add, you know, this is along the lines of what we're discussing here, but you know, the Saffir-Simpson scale is great, but it doesn't do us any favors in this messaging because there's this extra layer that's always needed beyond that. Okay, it's a Cat 4 headed my way. Okay, well, what does that mean for me is like the next question. You get all sorts of different flavors of that since it's just based off of a single point value max wind somewhere in the circulation, right? And so sometimes you get a very asymmetric storm, thinking of Milton as it made landfall, right, in the southern part of the circulation. Again, if you were south of that center, I mean, I'm not saying there weren't impacts, but you weren't getting major hurricane force winds in that area, at least consistently, Cat 4, I should say. And again, there's this extra layer. So how do we sort of take the next step and, you know, like you were saying, improve our communication to a point where there's less extra steps and less extra questions that need to be asked beyond that. I don't have any answers, but I think that, you know, we need to consider it.
G-Sign does.
Yeah. So I got a practical application of this. What's your percent chance of having a 10-day power outage? And what wind speed maps to that? Right? I bet a lot of people would take action if they had a 60% chance of a 10-day power outage. You know, stuff like that, right? That's just one example.
Yeah, it's a great example.
Sorry.
No, I was just gonna respond to what you said, guys, about, so how do we improve communication? Part of it is understanding that you don't say the same thing to everyone. So there's a specific thing called audience analysis, and it's targeting specific messages to specific people. I think someone here also mentioned like end users. You have a gazillion different varieties of end users. And the reality is that, yes, you could probably say a Cat 4 hurricane is coming to an emergency manager, maybe to some broadcast meteorologists. They're going to know exactly what you're talking about. But for other parts of the population, they have no idea what that means. And so it's okay to use that vocabulary for people that are aware of it. But then for other folks, we need to make sure that we're talking more the impact side, right? That means a tree's going to go down. That means your roof's going to go off your house. Those. Exactly. And right. Exactly. So it's about really doing, which is really funny because when Andy asked you, so what are all these questions that you have? All your questions were about people, were social science questions. Like they weren't modeling questions, right? So that kind of gave me hope. So there's a space, right? So if we do more research and find out what people want to know and when they want to know it, how does that impact the work that you all do? Would that make you prioritize something a little bit more? Would you focus on doing something that would help that as opposed to something else? So it's about how do we in our resource confined universe prioritize what we all want to do, but do so in a manner that we know is going to have greater impact down the line. And then how do we have that conversation together? How do we continue to sort of be in this space where we're asking those types of questions, trying to get some answers to that, and then actually direct our work in response to those answers that we're looking for?
Since I didn't use slides, you won't see it, but I had one up basically of a bridge. And on one side is science. On one side of the canyon. On the other side of the canyon is communication or service. And for a long time, we've sort of kept those things separate, science and service. And we can't do that anymore. We need to bridge that. And that's what we're talking about here. You're really bridging. Oh, you're going to show it maybe real quick. But basically, we need to come together and collaborate on this message. Oh, I saw it. It was the other slide set. Yeah, you go down a little bit. It's down there. There it is. So really simple, but it's one that because the discussion comes up a lot. I may just hit it a couple of times there. It'll come up. But it really is taking your work, collaborating on that to create a message that's effective to our core partners in our communities. And your role basically is to start creating that story, that message on that science side. But science is important. It's just as important as communication and vice versa. We have to have it, but it's not separated. You have to kind of think about the whole. And it takes that collaboration, which we're doing here at this level. It takes it on the forecast level to collaborate that. And this is where I think as an agency, we're going. And we're going to IDSS even more so. We've been doing it. And we know our director wants us to even more so really be focused on the idea that we're embedded with our core partners, our communities, and talking to them. But we can't talk to them if we don't have the right information, the right data, the right modeling. That's what a forecaster in an office is using. Or if they're actually on site, maybe in response to a disaster, what are they using? They're using model data to help interpret that information so they can give it to a core partner who's making life-saving decisions. So I just want to make sure when we talk about these things, it's not an either or. It's not leaving science behind. Science to me is only becoming more essential. It's more important. It's how do we draw from it to effectively communicate a message? So.
Kate Musgrave, Sierra again.
Thank you.
I would actually step that back a little bit and compartmentalize a little bit more, and that we need those go-betweens. Again, this goes back to who is your end user? Who are you trying to communicate with? And as Maulers, we're not the appropriate to be communicating with somebody in Brickell or, Coconut Grove about, oh yes, you're going to lose power for 5 days, because you don't know as a science modeler, oh, are there lines above ground or are they buried? What's the pathways here? What we need to know is the information that the private industry needs or the emergency managers need to translate that into the end goal. So we can't necessarily integrate everything all the way to the final end of, telling someone they need to buy like 2 weeks worth of formula or something,
Right.
But we need to know the in-betweens of the hazards, what's needed at the intermediate steps to turn this into the specialized information that's needed by all of these different groups. Because if we try and, make one person or one group do everything, then it's not going to get done well.
Right. So very much as a team, and again, that you're serving, they're at different levels. And a lot of it's within the Weather Service itself. So you have those different, all the different offices that are engaging with their core partner directly that are helping making those decisions. So we might be toward the end. I'm just guessing. But any other questions before we end up? Otherwise, fantastic discussion. Thank you for being here on a Friday afternoon. I know some probably have to take off, so I will leave it there unless there's any more comments. Okay.